In the movies, hacking is usually portrayed as a high-speed sprint of furious typing and custom-coded cyber weapons breaking through military-grade encryption. But in the real world, the most devastating system breaches rarely rely on advanced software. They rely on simple human oversights. Take the target machine known as CAP. It's a standard Linux server, patched against all the latest known vulnerabilities. To get inside, we won't be using any secret, unreleased exploits. This port scan visualization reveals 3 entry points: FTP on port 21, SSH on port 22, and a web dashboard on port 80. Testing quickly shuts down easy access. Both FTP and SSH reject anonymous logins, locking those doors, leaving only the web interface active. So the front doors are bolted shut, the software is up to date, and we have no credentials. How exactly do you compromise a machine that refuses to let you in? Clicking around the internal web dashboard reveals a page labeled Security Snapshots, designed for a specific employee named Nathan. Selecting a recent snapshot loads a new page, and the web address ends with a very specific numeric path: /download/2. Without server verification, modifying a direct reference lets a user view someone else's data. This is an insecure direct object reference, or IDOR. Changing the URL's 2 to a 0 makes the server hand over another file, a packet capture, ending in .pcap. A packet capture is a literal recording of raw network traffic. Whatever was sent across the wire during that snapshot is saved in this file, and whoever configured this network made a critical error. They captured communications that were entirely unencrypted. When we open that file in a protocol analyzer, we can see every interaction that occurred on the wire while the capture was running. Because a user performed a login over an unencrypted protocol like FTP during that window, the sensitive data wasn't masked. The username Nathan and his password appear in the data stream exactly as they were transmitted, in plain text. A web developer assumed users wouldn't manually edit the web address. That single, unchecked assumption allowed an outsider to read unencrypted traffic logs, exposing passwords that protect the rest of the server. With Nathan's password secured, those previously locked network ports are now wide open. First, a quick login to the FTP server uncovers the initial user flag. Then, passing the exact same credentials to the SSH service on port 22 grants us command line access to the server itself. We are finally inside, but we are boxed in. Nathan is a standard user, meaning the operating system blocks us from viewing critical files or making administrative changes. To gain total control, we need a path to the root account. We run an automated script called linpiece directly from the terminal, scanning the operating system's internal permissions for any hidden vulnerabilities or careless configurations. This diagram illustrates the specific misconfiguration we found. Usually, a program is either root or not root, but Linux capabilities allow for a more surgical approach. The Python binary was granted the cap setuid capability, permitting it to assume the permissions of any user. We instruct Python to set its user ID to 0, the number for root, and launch a new shell. The command executes without throwing any errors. The standard $sign on the terminal prompt vanishes, replaced instantly by the words root at cap, followed by a hash mark. We now completely own the target machine. You can lock every external door and patch every service, but if an internal application is casually granted the authority to make anyone an administrator, the entire security perimeter is functionally useless. We navigate straight to the administrator directory, extract the final root flag, and the machine is fully compromised. Breaking down the CAP machine reveals a chain of 3 compounding errors. First, the application suffered from an insecure direct object reference. The server completely trusted the numeric ID in the web address, granting access to private files without verifying if we actually had permission to see them. Second, network logs were captured and stored without any encryption. Exposing a packet capture is a severe liability on its own, but because the internal communications were sent in clear text, obtaining the log meant immediately obtaining usable passwords. Finally, the privilege escalation relied entirely on a misconfigured system setting. Handing out the capsetuid capability to a flexible programming language like Python gave any low-level user a built-in mechanism to become the root administrator. Real-world cybersecurity rarely comes down to repelling highly sophisticated attacks. Often, total system failure happens simply because the basic rules, like checking who changed a single digit in a web address, were ignored.